Hello everyone, Standard 10, Subject Maths, Chapter number 3, Pair of Linear Equation in Two Variable, Part 1. Okay, so look at over here, a pair of linear equation. The word linear, okay, we already know about a linear polynomial. Okay, you already learned in Standard 9th also, as well as in our chapter number 2 polynomials. You also studied about a linear polynomials. Okay, so a word linear is derived from the idea of graph of linear equation is represent nothing but a straight line. Okay, now what second thing you have observed about linear polynomial? That the degree should be 1. Okay. So, if my linear equation of one variable, okay, just forget about the linear equation. We already studied about the polynomial. So, a polynomial in x variable, okay. So, there is only one variable. So, linear polynomial in x variable. Okay, there is only one variable which is my x. How we can write that one? P of x. Okay, what is the general formula of linear polynomial in one variable? That is by only one variable. So that is ax plus b. Okay, what's the next condition over here? That a should not equals to 0. Why not equals to 0? Because in a linear polynomial, my degree should be 1. Okay, if my a equals to 0, I am getting a into x. This one part is 0. Okay, I am getting only b. That is my constant. Okay. So the next thing is degree should be 1. Okay, the degree should be 1 of linear polynomial. Okay, now let's consider this linear polynomial as an equation. Why I am saying equation? It means when you take any equation and just equate it. Okay, it means left hand side is equal to right hand side. You may think over here. So take one example. Example says x plus 2 equals to 0. Okay, so this is my linear equation. Why I am saying equation? Because when you equate it, here the sign is equal to. So we are saying this one is my linear equation. Why I am saying linear? Because the degree of my variable is 1 only. What is the degree over here? 1. So I am saying that this one is my linear equation. Okay. Now, what are the zeros? We studied about zeros of linear polynomial. So, how many zeros of a linear polynomial? Okay, it has exactly 1 0. It has exactly 1 0. Similarly, if you find a value over here which is equals to 0, it means you just replace x with any value and you getting is equal to your right hand side. That is the solution of this equation. Okay. Similarly, you have done in how to find a zeros of linear polynomial. It means you just write like this one, ax plus b. Why I am saying? If I replace my x with a, so my remainder should be equals to 0. Remainder should be equals to 0. Similarly over here, if I replace this x with any value, okay, and the resultant value should be equals to 0. Okay, so I am taking x equals to minus 2 plus 2. I am getting 0. Okay, so this one is my left hand side equals to right hand side. While I am equating this equation, I am getting my left hand side is equal to the right hand side. It means this x equals to -2 is one solution. Is solution of the linear equation x plus 2 equals to 0. So this one is the solution of the equation. Okay, it's exactly same like zeros of the polynomial. Okay, but the thing is given here in the form of equals to. Okay, now can you replace x with any other values? Okay, if you replace this x with any other values, what if I am take x equals to 1. So what I am getting over here? 1 plus 2, that is 3, that is not equals to 0. It means this x equals to 1 is not solution of x plus 1 equals to 0. Okay, not solution of a linear equation x plus 1. So exactly similar to zeros of a linear polynomial. In zeros of the linear polynomial, you have studied that they have exactly one and only one zeros. It means one solution. Similarly over here, in a linear polynomial of one variable, linear polynomial of linear equation in a one variable has exactly one solution. So you can write over here that linear equation in one variable has only one solution. You can take one more example. Okay, let me take. If I am taking my linear equation 2x plus 3 equals to 0, can you replace this x with any other value? Okay, so that you will get equals to 0? No, there is only one value of x which satisfies this equation. Okay, so there is only one value, that is nothing but you can solve this one. X, take this 3 to the right hand side, it means -3. So x equals to -3 by 2. So for this equation, there is only one value of x which satisfies my equation 2x plus 3 equals to 0. What that value? That x equals to -3 by 2. Okay, that is the only one value of x which satisfies this equation. Why I am saying satisfied? It means when you replace this x with this value, the resultant value you will get over here equals to 0. Okay, so we can say that a linear equation in one variable has only one solution. How many solutions? One solution. Linear equation in one variable. I am talking about one variable only. So one variable has only one solution. Now let's just move towards to the graph. Okay. So we have also learned a linear polynomials graph also. Okay, so what's that says that a linear polynomials graph gives a straight line only. Okay, now similarly a linear equation in one variable also equations also gives, because it's a linear only now. Here gives a polynomial, here gives an equation form. It means the linear thing, it means it gives a straight line over here. Okay, now we just talk over here. How many variables? In linear equation, there are two variables. Okay. So, for linear, it means the condition is the degree should be 1. So, you can write over here degree should be 1. Degree should be 1 only. Okay. So, linear polynomial in one variable, you have learned how to write its general formula, that is my ax plus b. Okay. So, similarly, if I am adding one more variable, it means the both variable contains a degree 1 only. So, how we can write that one? So, ax, let's say b1 plus some constant. Okay. Okay, I'm talking about equation. So, equals to 0. Okay. Now, where? What is the condition over here? Where a is not equals to 0. Similarly, where a and b, it's a and b both are not 0. Both are not 0. Okay. So, what I'm trying to say here, that what is the degree of this? If you forget this one, can we write in a polynomial form? Can we write? Yes, you can write, or like this way. P of x and y. P of x and y. If it's one variable, you write like this one. Okay. How many variables are there? 2 variables. So you can write P of x comma y. This way you can write a polynomial in a 2 variables. Okay. So let's just talk about zeros or say solution. We have learned that a linear equation in one variable has only one solution. Only one solution. What can we say about a linear equation in 2 variables? Okay. So, take one more example. I am saying that x plus y equals to say 3. Okay. So, this is nothing but my linear equation. Why I am saying linear? Because the degree of x is 1 and the degree of y is 1. Okay. So, this is my linear equation in 2 variable, x variable and y variable. So, x plus y equals to 3. Can you find a different value of x and y so that value satisfied this equation? I am saying that value satisfied this equation. It means when you put those value to this equation, the linear equation in two variable has infinite values, infinite solution of this equation. Okay, so infinite values of x and y in linear equation of two variable that satisfied my equation. So you can write over here that linear equation in two variable has infinite solution of the equation. Okay, infinite solution of the equation. Now, two things we have learned, that linear equation in one variable has one solution. Linear equation in two variable has infinite solution. Infinite solution. Okay. Now, let's move towards to his graph. Okay. Does it give a straight line? Yes, but obviously it gives straight line only. Why I am saying straight line? Because it's my linear equation. If the variables are 1, 2, 3, doesn't matter. Linear it means it always gives a straight line. Okay. So let's just see one graph. Okay. So we have learned a linear polynomial in one variable. Okay, when you draw a graph of linear polynomial, okay, if I am taking say x plus 1 equals to 0, x plus 1 equals to 0. When you draw a graph over here, so you found that, okay, so x equals to minus 1 only. So x equals to minus 1. That is the only point on x. Okay, that is the only point on x. So graphically we can say that a point which intersect on the x-axis, that is the solution of that equation. Okay, that polynomial we have learned this in a polynomials. Okay. Now, if I say, let me take this example only, x plus y equals to 3. So I am taking x and y is different value. Okay. So I am taking 0, getting 3. I am taking 3, I am getting 0. Okay. So again you can take, if I take x equals to 1, y equals to 2. Okay. So likewise you can find so many things. Now, just draw here 0, 0, 1, 2 and 3. 1, 2 and 3. There is no negative value, so I am not including this. So first one is x is my 0, then y is my 3. X is 3, then y is 0. When x is 1, then y is 2. It means somewhere over here. So when you draw a graph of this, okay, so what you observe over here, that these points are nothing but my solution of this equation x plus y equals to 3, because all these points satisfy my equation. It means in a straight line there are infinite number of points. So in each and every point on a line, so there are, we know that in a straight line there are infinite number of points are there. linear equation in two variable. Pair of linear equation. It means there are more than one equation. It means pair. There are more than one equation. Okay. If can we write in a general form? General form. Okay. General form. Okay. So I am taking a1x plus b1y plus c1 equals to 0. See, a1, b1 and c1 that are constant. Okay, and you can write whatever you want. Okay, that is they all are constant. We don't know these things. Okay. Now, what is the condition where a1 and b1 not equals to 0? Not equals to 0. Both cannot be 0. Now, a pair of linear equations, so I am taking a2x plus b2y plus c2 equals to 0, where a2 and b2 is not equals to 0. Okay, so a1, a2, b1, b2, c1, c2 that are constant. Okay. We want only thing is a pair of linear equation. It means both equations contain a same variable. Look at over here, x and y variable, x and y variable. So we call it a pair of linear equation. Okay. So we have seen that this they have same variable x and y. So, pair of linear equation in two variable has same x and y variable. Same x and y variable. And degree is always 1. That's why we call it a linear polynomial. Okay. Now, in general form, we can write like this one. Okay. Now, see, in standard 9, you have studied two lines in a plane. Okay. Two lines in a plane. Okay. In standard 9, you have studied that two lines in a plane. It means they both lines lie on the same plane. Okay. See, when we talk about two lines, we have to specify that both lines should be lie on the same plane. Okay. So about plane, you will study in your higher classes, but we just have to know that should be lie on the same plane. Okay, that is the only condition. So, line in a, now two line in a plane, you studied about that. So, the first thing you have observed that when you draw a graph of that two line, okay, so either it can be intersect, like that, right? Okay. So see, if my graph is this way and somewhere like this way, so this one is also intersecting. When you extend its tail, okay, let me extend it. When you extend its tail, okay, over here it intersect. So first thing you have observed that when two lines, either it can be intersect. Okay. Now, what is the second thing you have observed? So this one is nothing but intersect over here. So it can be this way also. So this one is also my intersecting. Okay. The second thing you have observed that both are parallel. Both are parallel. Okay, they never intersect. Now, third thing you have observed that both lines lie on the same. Both lines are just placed on others. Okay, both lines just placed on one another. Okay, these three cases you have studied. Okay, so first thing, that is intersect. Intersecting. Okay, the second thing is parallel. Okay, and the third thing, that is coincident. Coincident line. Okay, so this thing you have learned in standard 9. Now we continue in next lecture.